it is fun. I don't know if our neighbors care because it's a duplex attached to us, and it is like, but it's not late at night or early in the morning. So we just got it, and yesterday, I think, or no, 2 days ago, and we were going to bed. You know, it's like 8:30. We're like, all right, I'm gonna go to bed, Johnny, and it's like we're staring at the drums, and Jesse goes, say goodnight to the drum set. And he went over and just hugged. He's like, good night, drum set. I miss you. And so I keep staring at him. So he's into it. It's awesome. I always swore I'd never have a drum when I had a kid. Because I'd been in somebody's house and their kid had a drum set. The little kid was like, ba, 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 and you're like, and the parents were oblivious to like how obnoxious it was. But to see his enthusiasm of music, and then see him wanting to, like, he wants us to sing, which is funny, it's not like a drumming song, but wants to sing Jesus Loves Me, so he can drum with it. You know, he, and his love for like going to church and hearing the worship team. If drums are the catalyst for that, that's awesome. And I'm not opposed to drumming, I like drums. Just constant banging, but I know you can get the rubber drum sets.
Yes, that's right.
Or the covers, the pads. But as a kid, nobody wants a pad. I'm sure 3-year-old muting the drum set, like.
This is not gonna work.
So we'll endure for a little while.
Yes.
So, but I am excited about it, and so that's cool. So I'll show you the video tomorrow. You'll be pleased. So, okay, 12.5 is right triangle trigonometry, and so this goes back to Toa, which I've been referencing a lot. You'll also need to know that, right, for the unit circle quiz on the back side, right? It says in terms of opposite, adjacent, hypotenuse, and then it says in terms of x, y, and r, right? And so all that. So you have to know both, Ahsoka Toa. And this is referring to when you have a right triangle and an angle theta, and then the opposite of theta, the hypotenuse, and then the adjacent, right? So that's the basics of it. SOHCAHTOA, hopefully by now you know what that stands for, right? S is sine, opposite hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. We don't memorize an acronym for secant, cosecant, cotangent, it's just the reciprocal of it all. So. And with right triangle trigonometry, you're generally not going to see reciprocals when you're solving the problem, so you're not going to see a whole lot, if any, secants and cotangents and things like that. There's two things we discussed in geometry, which we will discuss again, and that is the angle of elevation and the angle of depression, okay? And so a classic example is somebody's flying a kite, here's your kite, and the angle of elevation from the person to the kite, it's always considered from the horizontal to the object up in the air, whether it's a kite or whether you're looking up at a building, so we say theta there. Sometimes, and then you go down from here and make a right triangle. Sometimes the question comes up like, well, is the angle of elevation from the ground or is it from the line of sight? Technically, if you were surveying, it would actually be from the line of sight, which would be your eye level going up. In general, though, for our purposes, we just assume it's from the ground, unless they say a person that is, 6 feet tall is flying a kite. What is the and then in which case you would have this picture that would look like this, and then the kite is, or the building, let's say, usually that would be like a building type problem. And the person is looking from here up to the top of the building, and then their line of sight is across like that. And then they tell you that the person is like 6 feet tall, and the angle of elevation would be theta in that case. So if they really separate it out, then you think line of sight going there, and then tack on 6 feet at the end type deal to find the total distance of the building. But in general, if they don't say anything about that, it's just going to be from the ground going to the object up. So, but just think horizontal elevation looking up is the angle of elevation. Angle of depression, is what most of you have right now, and that is a classic example, right? Is okay, there's a boat, there's a lighthouse, or somebody standing on a cliff.
That's what
What?
I was thinking more of the cliff one than the lighthouse one.
Yeah, the cliff on the edge of the cliff can where you jump.
Because he has an angle.
You shouldn't joke about that though. You're not on camera. So.
That's not up to YouTube's TOS.
No, that may get blocked. So, again, what it's going to be, don't worry about eyesight versus base unless they distinguish that, which I don't think they do in any of these problems. The error occurs is that when you draw the angle of depression down like this, I don't know about most people, if there is an error made, they call that the angle of depression. It's always from the horizontal, then the movement down. So that is not the angle of depression. Going out and then down, that is the angle that we're referring to, okay? So then, with that being said, though, things that you might need to remember is this horizontal and this horizontal are parallel. Parallel lines cut by a transversal, very good. What do we know these angles are? Equal. Anybody remember the name of those angles, like theta and theta?
Equal English?
Angular. Alternate interior angles, yeah. So that's something to make a note of, like, oh yeah, alternate interior angles are equal. Also, this angle and this angle are going to make a 90, okay? Other problems that you might have, so that's the angle of depression. Other problems you might have, like here, and then you have like a mountaintop, here, and you have a boat out here like this, and the boat is moving towards, when you think about, and then they're going to ask for what is the height of the mountain. Well, the height of the mountain, you're not going to worry about this down to here. In general, when they talk about the distance from the boat to the mountain and the height, what kind of angle measure are we going to want to make from here all the way over to here to make what kind of triangle? A right triangle. So there's a little bit of like discrepancy where if you were actually like surveying, it's like, well, the distance from the boat to the shore, and then you get to the center where the height actually occurs, you're not going to worry about some of those little details. Think, okay, they're looking to make a right triangle, and it's going to be a general angle of elevation there. The boat moves and it's a little bit closer, another angle of elevation. So you might have some problems like that, okay? So those are angle of elevation, or depression, angle of elevation, and then SOHCAHTOA, that's the concepts that we're going to be dealing with. When we go to solve right triangles, they have a bunch of triangles that you can, for your homework, that you're going to solve. General triangles, they give you some information and you need to solve. So we'll do one of those, and then we will do some practice on some story problem type ones, or looking at some shapes in terms of circles and trapezoids and things like that. So if they give you a angle, like so this one, it just says solve right triangle ABC. Oops, that's an ABC, and they give you angle. Let's go with B is 15.8. Angle B is 15. Now they tell you it's a right triangle because if they didn't tell you, and C is 68. If they didn't tell you it's a right triangle, then you wouldn't know, right? But they tell you it's a right triangle, so then you can solve for it. So with that being said, when they say solve, what they're looking for is all the unknown parts outside of angle C, and they actually have a picture for you, because otherwise how do you know C? And they say it looks something like that. Okay, so that's your triangle. So C typically ends up being the right angle. And so when you go to solve, the things you need to solve for all the unknowns except for C, because C is known. B is known here, and side C is known. You don't need to state the angle C is 90. But they do want you to state that what is angle A? Angle A is equal to something, right? And then does that require trigonometry for angle A? No, that just requires your knowledge of a triangle. How many degrees of a triangle? 180, but 90 in the two acute angles, therefore this is 74.2. Okay, good, 74.2 degrees. And then now we want to find out what side B is and what side A is. Now that's going to require some trigonometry initially, and then you could do Pythag. Don't ever forget about Pythag, a nice way to go. We'll talk about rounding errors though, or rounding issues. So let's start out with, how do I find B? Now, if you look at the picture, you could say, okay, if B is 15.8, I know 74.2 is exact because there's no rounding to get from here to here. So 74.2 is a very valid angle to end up using. We want to be careful when we use rounded values, but 74.2 is not rounded. So 74.2 there, if we wanted to use that angle, we know that we have unknown A, we have a known side C, unknown side B. So if I wanted to find, let's say A, what trigonometric function should I use to find side A?
Sine.
Okay, sine of
68 or no.
74.2 degrees, and sine says, hey, you've got an angle measure. What's the ratio of the
Opposite of
opposite of hypotenuse? What's the opposite? What's the hypotenuse? 68. So A is equal to what? Now the book will say 3 sig figs usually, or 2 decimals or whatever. The directions here said angle measures nearest tenth.
65.
Lengths to 3 sig figs. 65 what?
65.4.
65.4. Which makes sense that it's actually pretty close to the hypotenuse. 65.4. Why does it make sense that it's close to the hypotenuse?
because it's root 3.
No, that's only for 30, 60, 90s. 74 is close to 90 degrees, right? I mean, it's not really, really close, but it's close to 90 degrees, so it makes sense that the side opposite is close to the hypotenuse length. My picture is poor. Okay. Side A, careful, if you do Pythag theorem with this, is that a rounded value? Yes. So careful when you do Pythag theorem with that. Now you'll probably end up with a pretty close value, you'll probably be okay-ish. So, but your calculator, does your calculator have 64 point dot, 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 dot?
Yeah.
So what you can consider is simply doing, right, 65 point, was 4 rounded or was it 0.4? 3 something. So 65.4, just take that value on your calculator, right? Square it plus b squared is equal to 68 squared. So on your calculator, you should easily be able to square this value.
You also do answer.
Hit right answer squared, right? And then go 68 squared minus this answer squared, or just go 68 squared minus answer squared, and then square root it, and you'll have an exact value. So what do you get for B? Should be quite a bit smaller. Anybody?
18.51.
18.51. Seems reasonable. I'm waiting for other confirmation. Seems reasonable, though, because it's smaller, quite a bit smaller. And it's opposite of the 15.8 degree angle. Okay, if you wanted to know if that was exact, well, it is exact. You could, let's do this though, let's do Pythag theorem with only 65.4 squared, and then see what you get. So do Pythag theorem, but instead of all of the decimals, just do 65.4 squared, so 68 squared minus 65.4 squared, and then take the square root. So with a rounded b value, it's going to be 18. 18.62. And so you're already 0.12 off, which can be substantial. It's a big deal. Like, depending on what you're doing, right? 0.12 can be a big deal. So that's why exact values it's important, right? So, make sure you're doing exact values. The book, sometimes geometry book especially, they rounded early. And so then, they did this and then they come up with this or something. And usually though, so these other books are usually a little better with that. The other way you could do it though is if you didn't do Pythag, and I need to find some A, we already said was 65. Oh, did I say B was 65.4? I meant A was 65.4. How would I do B using trigonometry? So don't do Pythag, which is a legitimate way to go. Don't do Pythag. How do I find B?
Cosine.
Sure, cosine of 74.2 is ca, so it's adjacent over hypotenuse. And if you do that, you'll get out 18.51. B is equal to 68 times cos of 74.2. I'm sorry. Yeah, 18.51. Yeah, we're good. I was looking at my picture and got myself turned around. 18.51. Okay? So, trigonometry is a great way to go too, but you can definitely do Pythag once you have two of the sides. Questions on that? Okay. So they give you a picture here. It says an isosceles trapezoid. What's a trapezoid?
It's like a triangle with its top cut off.
Yeah, a triangle with its top cut off. So if it's an isosceles trapezoid, it's an isosceles trapezoid with its
Head cut off.
top cut off. Which means, what do I know about
Equal.
this and this? Yeah, equal. And so then they have these letters A, B, and then C, D. So they actually have it drawn for you. What might you know then about angle A and angle B? Equal, right? If it's isosceles of the base angles, what do you know about D and C? Also equal. So they say find the measures of the angles. They give you the height of the isosceles trapezoid is 6. When you talk about height, is the height of the trapezoid measured from A to D? For the height? No. It always makes what kind of angle measure?
A straight line.
Yeah. Well, lines are all straight.
The horizontal.
Unless you draw a line, the general idea of lines are straight. Think about drawing a line around the earth. Is that a straight line? No, it's a curve.
Yeah.
So, but outside, right, so it's straight here. Which is really interesting as you drive across America, you're just generally curving slightly.
I heard you could make like a two-sided polygon because of that. In the way the world works, you draw like a line, two lines of a sphere that like connect, kind of like
Yeah.
this.
So there's your altitude. And then it tells you the bases are 4 and 20, so like this. And they want you to find the angle. So you want to find angle A. If you find A, then you know B. And then if you find B, you know C, or vice versa. So how might I find A?
Oh, you can find the length of the bottom of the triangle.
Okay, meaning from here to here. Okay, how do I find that?
Well, so 4 is the middle section.
Yep.
So if you do 20 minus 4 is 16. And then
Okay.
divide that by 2 because there's one on each side.
And they're equal because it's isosceles. Yeah, divided by 2, so
8.
8. Okay. And then what do you know the hypotenuse is, even without your calculator, without Pythag theorem?
7. No. Yeah.
10?
No.
Yeah, because it's a
3, 4, 5.
3, 4, 5 Pythag triple. But definitely you can use your calculator. Call that 10. Alright, how do I find A?
Yeah.
Sine. We can do both, right?
You can do anything you want.
So 6 over 10, or sine A
Sine of A,
equals 6 over
6 over 10, opposite of hypotenuse. And then how do I find A?
10. Inverse.
Sure it's not the -1 button?
It is the negative one, right?
Yeah, inverse of A, very good.
Yes.
So what do you get for A?
36.87, right?
Okay, so 36 point what?
87.
87. Okay, couple different ways to find D. Like the easy way and the hard way.
Same thing we did for A,
Okay,
except with cosine. Would it be cosine?
Oh, or you can just subtract the by 90. Wait,
Is it what?
what are we trying to
At
find?
90 plus whatever that
Oh,
little
yeah,
triangle was there.
you could add 90 to A and then subtract that
yeah,
from 180.
yeah. So what you know is two parallels cut by A, transversal, right? And then alpha and theta, those are not alternate interior, they're consecutive
And they
interior.
equal 180.
And they equal 180, they're supplementary. Yeah, or you could recognize, find out what this angle measure is, add 90 to it. Or, so, right, 180 minus this is gonna give you the whole angle D. Or, you could do trigonometry and find part of D and say, you know, cosine of D is equal to adjacent over hypotenuse, or tangent of this little section is equal to opposite over adjacent. You can do trigonometry and find that, then add 90. Easiest thing would just be subtract from 180. So what do you get for angle D for the whole angle?
143.13.
143.13. Good. Rhombus, you're gonna have a question about a rhombus. They actually have a picture drawn for you, but what's the definition of a rhombus?
All sides are equal.
All sides are equal, good.
Wait, so then
Remember
opposite
it-
angles are the same.
Opposite angles are the same. The most notorious rhombus, or the one rhombus that we use the most, would be a square. But not all square, I mean, not all rhombuses are squares, right? So it just means all four sides are the same. It's like, you know, it would be like a squished diamond, if you will. So all those are the same. Opposite angles are equal.
Two pairs of parallel lines.
Yeah, because it's a parallelogram. Then, do you remember anything about that diagonal? Bisects the angle, and then the diagonals are
90.
perpendicular, and then they bisect each other. So a lot going on in the rhombus. So don't move. Don't move. That just looks very hard.
Wow.
I can't do it. I had a teacher, Dr. James Mann in college, and he would, you'd ask him a question, and he would start working on it on the board. Then when he got stumped, he'd kind of pause up here, you know, he's working, and then he'd get stumped. And you knew he got stumped because he'd go like this every time. And then he'd turn in the class and let's go to the next one. And then eventually he would release the arm. I think he never knew. He knew, like, as a class, he'd ask a question and they'd be working, and all of a sudden he'd go like this, and everybody's like, and we were like trying to stump him. It's just like, I don't understand 13,
He's like, I don't understand it either.
and hold that pose for a while.
Make your arm hurt.
Yeah.
Yeah, I used to do that as like a resting pose.
Oh. A
It
resting pose.
You do
Yeah.
that a lot. You're always stretching, like you're always switching
because,
your
like,
arms.
my physical therapist told me I'm like hypermobile or whatever, so my body thinks it needs to stretch more often than it does.
Alright, so you're at page 578. We'll look at a couple story problems. Just to set them up. Setting them up is, you know, if you will, the hardest part, and then the trig usually isn't too bad. So number 2, we're not going to solve a bunch of these, just try to set a few up. Number 2, on page 578, it states, a boy flying a kite, classic example, is standing 30 feet from a point directly under the kite. If the string to the kite is 50, find the angle of elevation to the kite. So, we have our ground. We have somebody standing there. We have a kite. Okay. The string to the kite, it tells you. How long is the string to the kite? 50. So that's 50. And then tells you one other piece of information.
The kite is standing 30 feet from a point directly under. The boy flying the kite is standing 30 feet from a point directly under the kite.
If it's directly under, what kind of angle measure? 90. And then what is this?
30.
30. There you go. And then want to find the angle of elevation. Where's the angle of elevation?
From the boy, right there.
From the boy.
From the wag bag.
From the wag bag. You can find the other side if you want. Don't need to. What's the other side? 40. But you could, so then if you know that it's 40, you could use sine, cosine, or tangent. And then we just solve for theta. How do we solve for theta? If we only knew the 30 and the 50, you don't want to mess with understanding that it's 40 on the other side. What trigonometric function would I use there? Cosine, because you're looking, you have an adjacent and you have a hypotenuse. And so cosine of theta equals 30 over 50, and then you get theta. And maybe you already did that. I don't know. We weren't going to solve, but that was pretty straightforward. And? Okay, nice. Let's talk about number 10. A camping tent is supported by a rope stretched between 2 trees at a height of 210 centimeters. If the sides of the tent make an angle of 55 degrees with the level ground, how wide is the tent at the bottom?
He's thinking.
So you have your tent.
No, I thought it was like in the air or something. I was really confused on what it even looked like.
There's your ground, right? But the tent makes a what with the ground? Not 90, tell you.
55.
55 degree with the ground. So if you think about like the tent, so yeah, if it's isosceles,
The top of it, 90.
top would make a not 90, 80,
I think you. Yeah. Oh no, no.
okay,
70.
70.
Yeah.
Backtracking to 70.
It says that added together is 110.
Okay, so that's a 70. Then it says it's supported. The rope stretched between two trees at a height of 210. So whatever, here's your tree, and it's supported by a rope stretched between the two trees. Because it is only a rope, if you think about like the laws of physics, if it's only a rope between one tree, is that going to hold it up? Now a lot of like this would be a tent that I remember when I went to college, they had a introductory program for all. Optional, but for incoming freshmen. And so incoming freshmen could sign up for what they call High Road. And what it was, they advertised it as like a wilderness experience, get to know new incoming freshmen. And it's, I think it was like 18 days or something before school starts, and you get a couple credits. And then you can work with some professors and stuff. So, okay, sign up. And what it was like, you go to the camp, you meet everybody day 1, you get into your group. Day 2, you do a little like canoe orienting, figure out how to rescue yourself in the water if your canoe flips over. And then they give you a pile of food and tell you pick out the food you want for the next 14 days. And it's like hardtack, like dense bread, high caloric, dense bread, dehydrated soy beef.
Astronaut rations.
Which is soy beef that's actually not a thing, right? Because beef is, but it's soy, beef. And then they're like, okay, here's your tarp. That's your tent. Just a plastic tarp. Here's a sleeping bag. And we're going to set off for 14 days in the wilderness. The idea was break you down so God could build you up. In some ways it was incredible, in other ways it was absolutely miserable. But every time you went to set up a tent, you just had a plastic tarp, which the mosquitoes really, and a bug net, and the mosquitoes were bad. So it wasn't like, hey, let's sleep under the stars, because the mosquitoes were so bad, they would just like destroy you. So you always had to find 2 trees, and then you take your plastic tarp, and you get a bunch of like leaves or whatever you could stuffed in there and make a little ball like that, and then tie the twine that they gave you around it and stretch it to a tree and stretch it to a tree. And then you do it on the other end of the tent as well.
Yeah.
So were you guys in like groups or by?
You would sleep by yourself. I think Zach, this kid Zach and I, we bonded together, like, let's make a tent together. we made our own tent. Like, combined it so we could have like friendship. Suffering out there so bad. And it was a good experience, but it was tough. So
You came out alive.
we came out alive. I remember the one time we found a road to sleep on, like a dirt road, and we were like really pumped. It was like through the woods, so there's like big ruts, and so it was like, but we were able to like stretch between 2 trees. We were really pumped, because everywhere else we were sleeping was just like rough Wisconsin woods, not meadows. It was just, so sometimes like sleeping over like a log kind of misery. And that night it like rained a ton.
Oh no.
And we were in the bottom of like a little bit of like a depression on the road, right? So all the water. And I remember waking up in the night, like hearing the rain, you're like, oh, who cares? But then in the middle of the night, you're like feeling wet. And then I remember I rolled off of my sleeping bag, and we had these little thin foam pads. And I pushed down on the sleeping bag in the pad, and it just bobbed. It was just floating in this much water. And so I was like, well, we've got 4 hours till daylight, so you just sat there waiting.
No.
You had no, I don't know if we had headlamps.
Oh gosh.
Oh.
You didn't have phones, there's nothing.
Yeah, no.
You just sat there waiting.
That's miserable.
And we had run out of food, and they had resupplied us, but they resupplied us with hard refried beans that you're supposed to rehydrate, and then like onions, and you're supposed to make like refried beans and tortillas or something. I don't even know if we ate all the tortillas, we were so hungry, but we didn't wanna make a fire to cook the beans and the onions, so I remember us eating raw onions.
No,
It's like an apple. And the refried beans, we tried crunching down on it, it's like, couldn't do it.
So nasty.
And the next day, that was our final night, and the next day we had an 11-mile run back into camp for like the final, like, then you had 3 days back at the camp, which were glorious, so it was like the celebration run of like, you've just been beaten down.
This sounds glorious.
And the next morning, we're like heading off on the run at like 6 a.m. And everybody from all the other groups are all in the general area, but you haven't seen anybody, but everybody's strategically placed, and then it's all basically an 11-mile run, and everybody funnels onto the same course. You know, they have it marked out, and eventually you're all of a sudden seeing other people from these other groups, and all of us, we've just been pounding hard refried beans and raw onion, and we're like, our group was just peeling off into the woods partway through the run, just having explosive gastrointestinal issues.
Oh,
you know? I remember Bruce Binger, he was like, I think he had to pull over like 4 or 5 times, like disappeared. It was so bad. I'll never forget eating that onion, just thinking like, it's not good, but I don't care, I'm so hungry. So, anyways, somebody food. Alright, so, that being said, we have our tent, it's attached up there, hopefully the ground's flat, hopefully it doesn't rain, hopefully no mosquitoes, and hopefully I do more than hardtack.
Hopefully no gastrointestinal
Yeah.
problems.
We need to make a right triangle, because our goal is to figure out what? I mean, like, what does it state? How wide is the bottom of the tent? So we gotta figure out from here to there.
Yeah.
So it's not a 90 until we make it a 90. Now we've made it a 90. What do I know about this dotted length from the top to the bottom?
210 centimeters.
210. And then can I find then what we'll call this x? This is also x. Can I find out what x is?
Yes.
Yeah, do I know the hypotenuse?
No.
No. So when I don't know the hypotenuse and I actually don't want to find the hypotenuse,
Use tangent.
what trigonometric function? Tangent, right? So we go tan of 55 is equal to the opposite over x, multiply both sides by x, divide by tan of 55. So x would be equal to 210 divided by tan of 55. And then whatever you get for x, you multiply that by 2.
294.
294?
Yeah.
That sounds good to us. That matches the book answer. Okay, not due tomorrow. This will be due Monday, but unit circle quiz